Organic nomenclature flowchart. Start here. Find the longest carbon chain. Count the number of carbons. The number of carbons determines the name of the alkane. If an atom of hydrogen on an alkane chain is replaced by another element, for example oxygen, the longest carbon chain is the alkane root word used in naming the compound. If the compound has only single bonds and no functional groups are attached in place of hydrogen on the alkane chain, the name of the alkane is the name of the compound. The number of carbon atoms in the carbon chain determines the name of the alkane. Methane has 1 carbon. Ethane has 2 carbons. Propane has 3 carbons. Butane has 4 carbons. Pentane has 5 carbons. Hexane has 6 carbons. Naming alkanes continued. Heptane has 7 carbons. Octane has 8 carbons. Nonane has 9 carbons. Decane has 10 carbons. Naming alkenes and alkynes. If there is one or more double or triple bond in the carbon chain, the compound is an alkene with an E or an alkyne with a Y. If there is a double bond between 2 carbon atoms, the compound is an alkene. If there is a triple bond between 2 carbon atoms, the compound is an alkyne, the Y. If there is a double or triple bond between 2 carbons in the carbon chain, go to slide 6. Otherwise, go to slide 9. Naming alkenes. If the carbon chain has one or more double bonds between the carbon atoms in a carbon chain, the compound is an alkene, ending in ene. If there is one or more double bonds in the carbon chain, go to slide 7. Otherwise, go to slide 8. Naming alkenes continued. Add a number to indicate on which carbon in the carbon chain has the double bond. Number right to left or left to right to get the lowest number possible to identify where the double bond is on the carbon chain. Change the ane suffix on the alkane to the suffix ene. The suffix ene indicates there is at least one double bond in the carbon chain. Naming alkynes continued. If there is at least one triple bond between carbon atoms in the carbon chain, the compound is an alkyne with a YNE. Add a number to indicate the location of the triple bond. Number right to left or left to right to ensure the lowest possible number to identify where the triple bond is on the carbon chain. Change the ane suffix of the alkane root word to YNE suffix. The YNE suffix indicates there is one or more triple bonds on the carbon chain. Naming alcohols. If one of the hydrogen atoms on the carbon chain is replaced by an oxygen atom, which is bonded to the carbon atom in the chain by a single bond, and the oxygen atom is also bonded to a hydrogen atom by a single bond, the compound is an alcohol group. This functional group of an oxygen atom bonded to the carbon chain and to a hydrogen atom is often called the OH functional group. If one of the hydrogen atoms has been replaced by an OH functional group, go to slide 10. Otherwise, go to slide 11. Naming alcohols continued. Add a number to indicate where the alcohol function group, the OH group, is attached to the carbon chain. Count the number of carbons right to left or left to right to get the lowest numbers, which indicates where the alcohol group, the OH group, is on the carbon chain. Find the longest carbon chain, which is the alkane root word. Drop the final E on the alkane name and add the suffix OL. The suffix OL indicates the compound is an alcohol. Naming carboxylic acids. Carboxylic acids are also called organic acids. If the compound has a double bonded oxygen and an OH group to the same carbon atom in the chain, the compound is a carboxylic acid. If the compound has a double bonded oxygen and an OH group bonded to the same carbon atom in the carbon chain, go to slide 12. Otherwise, go to slide 13. Naming carboxylic acids continued. Count the carbon atoms to find the longest carbon chain. Drop the final E of the alkane root word and add the suffix OIC and the word acid to the name of the compound. The suffix OIC followed by the word acid indicates the compound is a carboxylic or organic acid. Naming aldehydes. If the compound has a double bonded oxygen and a single atom of hydrogen bonded to the carbon at the end of the carbon chain, the compound is an aldehyde. If the compound has a double bonded oxygen and a single atom of hydrogen bonded to the end carbon, go to slide 14. Otherwise, go to slide 15. Naming aldehydes continued. If the compound has a double bonded oxygen and a single atom of hydrogen bonded to the carbon at the end of a carbon chain, the compound is an aldehyde. Count the number of carbons to find the longest carbon chain. Drop the final E of the alkane root word and add the suffix Al. The suffix Al indicates the compound is an aldehyde. Naming ethers. If there is an oxygen atom between two carbon atoms in the carbon chain, the compound is an ether. If the compound has an oxygen atom between two carbon atoms in the carbon chain, go to slide 16. Otherwise, go to slide 17. Naming ethers continued. Count the number of carbon atoms in each carbon chain on either side of the oxygen atom. Name each carbon chain in alphabetical order. Drop the ane suffix of the first carbon chain and add the suffix YL. Drop the ane suffix of the second carbon chain and add the suffix YL. Add the word ether. Naming ketones. If there is a double bonded oxygen attached to a carbon in the carbon chain and not on the end carbons, the compound is a ketone. If there is a double bonded oxygen attached to one of the carbon atoms in the carbon chain and not on the end carbons, go to slide 18. Otherwise, go to slide 19. Naming ketones continued. Count the carbons to find the longest carbon chain. Add a number to indicate where the double bonded oxygen, the ketone group, is attached to the carbon in the carbon chain. Drop the final E of the alkane root word and add the suffix ONE. The suffix ONE indicates the compound is a ketone. Naming esters. If the compound contains a double bonded oxygen to a carbon in the carbon chain and a single bonded oxygen to the same carbon, the compound is an ester. If the compound contains a double bonded oxygen to a carbon in the carbon chain and a single bonded oxygen to the same carbon, go to slide 20. Otherwise, go to slide 21. Naming esters continued. First, count the carbons attached to the single bonded oxygen. Drop the ane suffix of this alkane carbon chain and add the suffix YL. Second, count the carbons attached to the double bonded oxygen. Drop the final E of the alkane root word and add the suffix OATE. The suffix OATE indicates the compound is an ester. Naming amines. If there is a nitrogen with two attached hydrogen atoms on a carbon in the carbon chain, the compound is an amine. If the compound has an amine group, the nitrogen with two hydrogens attached, connected to a carbon in the carbon group, go to slide 22. Otherwise, go to slide 23. Naming amines continued. Count the number of carbons in the carbon chain to identify the alkane. Use a number to indicate the carbon where the amine group, the NH2 group, is attached to the carbon chain. Drop the final E of the alkane root word and add the suffix amine, A-M-I-N-E. Naming halogenated hydrocarbons. If a hydrogen atom on the carbon chain is replaced by a fluorine, chlorine, bromine, or iodine atom, the compound is a halogenated hydrocarbon. If a hydrogen atom on the carbon chain is replaced by fluorine, chlorine, bromine, or iodine, go to slide 24. Otherwise, go to slide 25. Naming halogenated hydrocarbons continued. Count the number of carbons to determine the alkane root word. Place a number or numbers to indicate where the halogen atom or atoms have replaced the hydrogen atom or atoms and are attached to the carbon chain. Use the prefix of the halogen and add to the root word of the alkane. If more than one halogen atom has been attached to the carbon chain, use the prefixes di for 2, tri for 3, and so forth to indicate multiple atoms of halogens. The prefixes are fluoro for fluorine, chloro for chlorine, bromo for bromine, and iodo for iodine. Aromatics. If the longest carbon chain is in a circle, the compound is an aromatic. We will not discuss aromatics in this course.